Hi everyone, welcome to our webinar today. The topic for today's webinar is peer influence in residential solar adoption, new research from Berkeley Lab. This webinar is being presented by Clean Energy States Alliance, and we are very excited to have guest speakers with us today from Lawrence Berkeley National Laboratory. But before we pass it over to them, I'd like to go over some webinar logistics. If you'd like to minimize the webinar viewing panel, you can do so by clicking on the orange arrow that you see circled here. You can also click on the orange arrow to expand your webinar console. One of the things that you might like to do on your webinar console is to submit your questions and comments. We will be saving 15 minutes following our presentation for a Q&A with the audience, and we will get to as many questions as we can. To make sure that we get to your question, do type it in when you think of it. Don't wait until the end. And finally, this webinar is being recorded. Slides and a recording of today's webinar will be sent to you via email within 48 hours. You can also find all of these materials posted on our website at cisa.org/webinars. This is a good URL to know because it's where we post all of our upcoming and archived webinars. And with that, I'd like to pass it over to our host for today's webinar, my colleague, Matt Ohloff.
Great, thanks so much, Zareen, and thanks everybody for joining us today. As Zareen said, my name is Matt Ohloff. I'm a project manager with CISA. CISA is a national nonprofit coalition of public agencies and organizations working together to advance clean energy. Next slide, please. CISA works with state leaders, federal agencies, industry representatives, and other stakeholders to develop clean energy programs and inclusive renewable energy markets. CISA is a membership organization. You can see logos of our member organizations here, which are mostly state agencies. Next slide, please. So today's webinar is focused on two reports recently released by the Lawrence Berkeley National Lab that highlight the influence of both residential and non-residential solar installations on nearby residential solar adoption rates. So the two reports, the first one shown here, entitled "The Role of Peer Influence in Rooftop Solar Adoption Inequity in the United States," explores the effects of residential peer influence on individual adoption of rooftop solar. Next slide, please. The second report studies the influence of non-residential solar panels on residential solar adoption. Next slide, please. Here are our speakers that we're joined by today. We're joined by Galen Barbose and Eric O'Shaughnessy of the Lawrence Berkeley National Lab, who authored these reports, and we'll be presenting their research and findings. Galen Barbose is staff scientist in the Energy Markets and Policy Department at the Lawrence Berkeley National Lab. Eric O'Shaughnessy is an independent renewable energy research consultant. His research focuses on econometric analysis of distributed energy resources and volunteer green power markets. Their presentations will be followed by a Q&A session. Please submit any questions during their presentation in the questions box in the panel here. So thanks again for joining, and I'll go ahead and pass it over to Galen and Eric.
Great, thanks, Matt. Thanks everyone for joining us today. We're excited to be able to share with you the results of not one, but two recent papers that we've published. I'm going to hand the mic over to Eric momentarily, who will really be doing basically all of the presentation duties. But I wanted to just first give a little bit of context behind this work, particularly kind of framing it within the larger body of work that we've been doing at Berkeley Lab over the last few years, focusing on essentially issues related to solar adoption, equity, and access, especially in the residential rooftop PV market. And so for those that aren't familiar with this work of ours, really the foundational piece for much of our work in this space is a data set and an annual report that we update each year, focused on describing income and demographic trends for residential rooftop solar adopters. Some of you may be familiar with that data set. But for those that aren't, this is a detailed address level data set covering basically 80% of all rooftop solar PV adopters in the country. The annual report really just focuses on basic descriptive trends, but then we leverage that data for a whole variety of more in-depth topical analyses, like the two studies that Eric will be talking about here today. So with that, I will just hand things over to Eric. Take it away.
Great, thanks, Galen. So I'll be talking over the course of the next 35 minutes or so we have plenty of time for Q&A about two studies. Flash a disclaimer in front of everyone. And I always like to put a summary up front while I have everyone's attention and kind of establish the key points. And if nothing else, we can come away from this webinar to hold these key points in our minds. So quick summary of the context here and why we're doing two studies in one today. It's around this idea that the demand for a lot of emerging technologies can be influenced by the adoption decisions of peers. I'll get in a bit later about what exactly I mean by peers, but essentially it means that technology adoption can be contagious. And this is something that's very clearly demonstrated for rooftop solar. You get these clustering of rooftop solar panels because you have this social influence, or something that you might often call a peer effect. So this is something that a lot of people have looked into, and recently it occurred to us to explore this some new angles on the role of influence in solar adoption. So we looked at two new questions. The first is, how does influence vary across household income levels? And the second is, does influence operate across different customer types? By that I mean we have residential customers, but there's also a lot of non-residential institutions that adopt solar, like businesses, government institutions, and houses of worship, to name some examples that we'll get into. The key findings. So right off the bat, these are kind of the three high-level points. Peer influence does affect household adoption decisions at all income levels. I think this is sort of an important takeaway, that influence is not something that's somehow restricted to specific types of adopters, and I'll get into the context of why we might think that later on. One particularly interesting finding from the first study is that influence is stronger within income groups. So the degree to which, for instance, a low-income household may be motivated to adopt solar is greater when a low-income household sees another low-income household adopt. And that may seem intuitive, and we'll talk later about why that finding is both interesting and potentially useful. And then in the second study, the key takeaway is that we do find that solar installations on non-residential buildings influence residential adoption decisions. So for instance, commercial buildings, government buildings, schools, and houses of worship all seem to have this influential effect. I'm going to cover two studies in this webinar, and I'm tying them both together, but still I'm going to cover tons of information, and there's so much more in the actual studies. So anything I gloss over here, it is very, very likely that you can find an answer to it in the original study. We'll have time for Q&A, but only so much. So particularly when it comes to the data and methods behind these studies, we just won't be getting much into those details today. I definitely encourage folks to go to the links here and check out the studies. And also to recognize that this is a group effort. You know, Galen and I were involved in both studies, but our co-authors are recognized here on this slide. So we thank them all for their inputs in both these studies. The big question tying the two studies together is, what drives rooftop solar adoption? There's lots of research on this question, because if you think about rooftop solar playing a key role in grid decarbonization or renewable energy deployment objectives, we need a lot more of it. We're at something like 4 million adoptions to date. There's 100 million or so households in the US. There's a big gap. So a lot of people are interested in what has driven rooftop solar adoption to date, and maybe can we use that information to drive more adoption in the future. Typically, this is the model. Most research focuses on the personal incentives. So thinking about an individual household making this decision on an island, looking at, say, their house electricity rate, or maybe think of it as an environmental decision. But the model essentially says that individual households make individual decisions. Another way of looking at it is that these decisions are somehow mutually influenced. So the decision of one household or non-residence institution may affect the adoption decision of other households. We often use this term peer just to emphasize that this is typically implying that there's some social connection between the two. So two peers may influence the adoption behavior of each other. So this kind of influence, social influence, interpersonal influence model has been really interesting. As I mentioned, there's been over a decade of research on solar demonstrating this point. So it's clearly established that rooftop solar adoption is at least partly driven by social influence. And one thing to mention here is that influence can operate in a lot of ways. So it might be the one that people often think about is the fact that rooftop solar is visible. So you can drive down the street and you see rooftop solar on your neighbor's rooftop, and it might just occur to you, well, if my neighbor got rooftop solar, why can't I? So that visibility does matter, and there's research showing that that's really important. It could also be interactions. It could be two neighbors speaking to each other, or it could just be a friend visiting from out of town saying, I got solar, and that might spark the adoption. So there's these kind of active versus passive measures of influence. Active being that a previous adopter talks to or somehow directly communicates their experience, versus a passive one where maybe one individual just sees panels on a rooftop. Both of those count. So when we talk about influence, it's a broad range of influence. It's no specific mechanism. And I'll get into a bit why that matters later on. So that's the big framework that ties the two studies together. And now I'll get into them starting just in this order, I guess, because this is the chronological order in which we did the studies. But the first one, looking at two different research questions. The first one, does peer influence operate at all income levels? I'll get into why we're thinking about income at all. And the second study, looking at if non-residential installations influence residential adoption decisions. So beginning with study one. The background here is that rooftop solar is diffusing through the population, which is a fancy word of saying that it's slowly trickling down into different households as more households adopt. But a key bit of context is that rooftop solar, or really all technology adoption, tends to begin inequitable in the sense that early adopters are high income because the technology is relatively high cost, and then it diffuses into lower income levels. So this plot here on the right just shows this is the percent of adopters earning less than the national median income. So if rooftop solar was just randomly distributed across households, you'd expect that number to be 50%. It's much lower, but it's creeping up over time. And again, this is consistent with all sorts of technologies. They tend to have this diffusion pattern. But nonetheless, one implication of this for influence is that influence has primarily driven adoption among relatively affluent households. So if we have a bunch of rooftop solar panels installed in relatively affluent neighborhoods, that means that the households that are being influenced by those systems are likewise themselves more likely to be relatively affluent, and it can contribute to this cycle of adoption inequity. So we thought it'd be a nice study to look at how much does social influence contribute to adoption inequity and different adoption levels across income levels. This is probably the most methodological looking slide, but I'll unpack it here. So if folks took at least Econ 101 at some point, you can think about demand curves and demand. The demand for a product like rooftop solar is a function of a bunch of stuff, but it's the price and then maybe, I don't know, your affinity with new technology or personal taste, whatever it is. And essentially with peer effects, this is peer influence, what's asserted is that a part of that demand function is the demand of other individuals. So if I am customer J, my demand for rooftop solar is a function of all customers that are not me. That is, if my neighbor adopts, that increases the probability that I adopt myself. That's the underlying framework behind peer effects modeling, and really the whole theory behind this. So that the demand curves or demand functions of individuals is a function of demand of other people. That's a way that we can work this into quantitative models. And I'm not going to get into the specifics of exactly how that's translated into statistical modeling. We do that and did that in previous webinars, and it's a lot of details, obviously, in both papers. But if you can just kind of keep this mental model in place, the results will work, make it forward as in this webinar. So our data set, as Galen mentioned, we have the benefit of having insights on something like 80% of rooftop solar adopters. We use a chunk of that rooftop solar adopter data in this study. And again, I'm not going to get into the details of the study sample, but it's rooftop solar adopters that adopted from 2010 to 2020. And as you see here, it's pretty broadly geographically distributed. There's high concentration in places like California and Hawaii and some northeastern states, precisely because those states are really active rooftop solar markets. And just to further establish some intuition before getting into the results, exactly what are we doing to establish this relationship? So we want to model the effect of a previous adoption on a subsequent adoption decision. So that means we need at least two types of data. We need some sort of date on when one household installed their system, and we need data on the date that an individual adopted or decided to adopt a system. And then if we can show there's a correlation between those two events, and we control for a bunch of other factors, we eventually get to a place where we can argue that the installation caused the adoption. Not every time, but by showing a statistical association, there's a causal model there. The challenge is we clearly don't necessarily observe these things. We don't know for certain when individuals installed, and we definitely do not know when individuals decided to adopt. The adoption date in particular is quite abstract. Maybe there was a moment when someone wakes up and decides, today is the day I'm going to adopt. That does not show up in our data set. But what we do have are two dates we do know, which is the dates that permits were applied for and issued. So all rooftop solar systems require permits. We have data on permitting, so we can use permit application dates and then count backwards to get to an imputed adoption date. And we can use the dates permits are issued and then count forwards to get to an imputed installation date. And then effectively what we're doing in these models is measuring the correlation between the imputed installation date and these imputed adoption dates. And then through a handful of assumptions and controls, we can take those correlations and make a causal argument that installations cause individuals to adopt. So with that, we'll get into some results. Always a challenge with webinars and research is that we can get real hung down or hung up on the numbers. Again, this is all in the study itself, but just the real basic here is we can interpret these numbers to mean the increase in the probability that an individual decides to adopt on some day. So the entire model, if we ignore income for a second, suggests that an installation within a census tract, in this case, and we can think about a neighborhood or some geographic area, increases the probability that another household adopts by around 1.8 percentage points. And that's really similar to previous estimates. There was an estimate from a decade ago that was about 0.8 percentage points. So all to say that the models seem to be consistent. We're getting similar results, which is always very encouraging in research. It's a substantial effect. That's a very, very big impact. Obviously, the baseline probability of adoption is a fraction of a percentage point, so it's a quite big leap. But really, the key question in this study are the peer effects or peer influence across household income levels. So this figure on the right demonstrates that key kind of finding here. LMI, in this case, low and moderate income households. LMI has lots of definition. Oftentimes in research, we use a practical definition that's just more easily interpretable. In this case, we're defining LMI as less than 100% of area median income. In the study, we use different definitions, and we present the results in different definitions. And the way we define LMI does not much affect the results. But we can split the data into LMI and non-LMI households and just look, do these peer effects change when we just look at LMI or non-LMI adoption? And what we find is that peer effects, that influence effect, is much stronger among non-LMI households. And it's much weaker among LMI households. I'll get into in a few minutes why that is and some discussion about it. But kind of the two takeaways is, one, first, it's not zero. Influence is clearly operating for LMI adoption. It is a factor. And two, that whatever that magnitude of influence tends to be weaker among LMI households. And then we were also interested is that does the influence vary across income levels? So within group, meaning the effects of LMI installations on subsequent LMI adoption decisions, or non-LMI on non-LMI, and across group would be the effects of LMI installations on non-LMI adoption decisions, or non-LMI installations on LMI adoption decisions. And what we find, which is one of the more interesting results in the study, is that the effects of peer influence are substantially stronger within income groups than across income groups. So effectively, when an LMI household, for instance, sees or interacts with a neighbor who also is LMI by the definition of the study, they're much more likely to then adopt themselves than if they had had that same interaction with a non-LMI individual. And I'll discuss in a second kind of some theories around that, but that's a good image to keep in mind. And then one final bit of results here is maybe some out there are already posing this question themselves. Well, we know that there's a lot less LMI adoption. So maybe these differences in LMI adoption rates and peer effects and magnitudes just reflects that fact. There's just less LMI adoption. So we thought to control for that, and it gets closer. So if you look at the orange bars, these within group effects, it seems like the magnitude of influence between an LMI household and another LMI household is pretty close, or closer to when you're looking at comparing it to non-LMI to non-LMI. But still, even when you're controlling for background adoption rates, it does appear that the magnitude of influence is considerably smaller among LMI households. So to discuss some of these points, the first, what explains this weaker LMI adoption? And it's one thing to bear in mind with peer effects. We're measuring a statistical association between an installation and an adoption decision that resulted in an installation. So the only way that the peer influence shows up is if someone actually went out and installed a rooftop solar system. We do not, for instance, it could be the case that an LMI household sees, say, a household adopt solar. They are very motivated. It changes their probability of adoption by a lot. But still, maybe they're a renter, or they live in a multifamily building, or they're just too budget constrained. There's all these barriers that LMI households face that keep them from adopting rooftop solar, and influence doesn't address any of that. So clearly, influence can only get you so far. It might get someone excited about solar, but it doesn't address these other practical constraints. So that's our key hypothesis for why the LMI influence effects are weaker. And then why do we see this stronger within income groups? This is really consistent with a lot of social science and really pretty intuitive. Clearly, if an LMI household lives in a mixed income area and maybe they see a relatively affluent neighbor adopt, they might think, well, sure, of course they can adopt, you know, the house, the big house or whatever. But if they see, you know, their neighbor that they know to be in a similar economic situation, they might think, well, sure, you know, if they can do it, I can do it. So it's very consistent with other social science, just saying that peers, when they're more similar in their characteristics, are more influential among each other. And a key implication of this is we have this idea in rooftop solar deployment of seeding, that maybe you could plant a seed in a certain community and that seed serves to influence other subsequent adoptions. And what this result really suggests is if you want to drive more LMI adoption, and there's lots of policies that aim to do that, there's lots of policymakers that are interested in driving more LMI adoption, the results would suggest that one way to do that would be to seed adoption in LMI communities. By that, I mean income levels do tend to be segregated across space. So in a relatively low income area, there tends to be less solar. The results would suggest it'd be more effective to seed adoption in LMI areas rather than, say, just supporting LMI adoption in general, where you might end up with certain LMI households in otherwise affluent or mixed income areas that adopt and don't subsequently influence further LMI adoption. Okay, with that, we'll move on to study number 2. So study number 2, as a reminder, we're looking at social influence across customer types. So still thinking about influence, all of the key concepts are the same. We're looking at statistical interactions between previous installations and subsequent adoption decisions. The key difference in this study are the actors. The background here, in basically all, we really only came across one study that had considered non-residential influence in any way, but the vast majority of previous influence research looked at influence between residential households. But for a variety of reasons, we began to get curious in the possibility of non-residential influence. So the idea here would be that a non-residential institution installs solar, and that solar influences the adoption decision of a household. And again, to reiterate this point, that could be passive or active. And in this case, there's some interesting stories that we could come up with, and we don't test them here, but we hypothesize about them. So passive, one could imagine if there's a really big rooftop on some library or non-governmental building, and you install solar, that's going to be really visible. If it's installed in the city center, a lot of people are going to see that. That could certainly prime people into thinking about solar. It could be a very effective form of influence. And then active, there are a lot of non-residential institutions that actively interact with lots of people. So a really good example here would be houses of worship that have direct interactions with their congregations. There's lots of houses of worship that are adopting solar. It stands to reason that at least some members of the congregation may become curious, have conversations, and that could spark a form of active influence between houses of worship and congregations. There's plenty of other examples you could think of, schools interacting with their educators or students, families, etc. So there's lots of different mechanisms that we could have this non-residential influence. So the key question here is, at the very least, is there the statistical evidence that this is happening? I think this is the only slide on methods in this study. So again, what we're doing is looking at statistical associations between dates. The same idea. We don't necessarily directly observe either of these dates. In this case, it's a little different. We're using, we have data on non-residential interconnection dates. That's the date that the system is interconnected with the grid. And we can work backwards to the non-residential installation. For residential, we're using a slightly different data set here. So in this case, we can look at the permit application and work backwards to the residential adoption. But the idea is the same. we're looking at a statistical association between a non-residential installation and a residential adoption. And then we're using a variety of methods and assumptions to make a causal argument that non-residential installations influence the adoption decisions of the residential households. And here, this study in particular, we had to take a different approach than previous peer influence studies. So this one is methodologically dense. There's lots of details in the study for those who are interested in that sort of thing. But this average treatment effect, essentially in the simplest possible terms, we can interpret these numbers to mean the increased number of residential adoptions in areas that have a non-residential system installed. In the study, we have this compounding effect. It's a bit different than the residential system, but just for the sake of this discussion, we can think of this as something like the increased number of adoptions per quarter. And really the key takeaway from this figure is that we see evidence of this. Basically, anything above the 0 line here is suggestive of statistically significant effects. So across all of these different types, we see these really convincing effects that non-residential systems influence residential adoption decisions. The different samples here are just different ways that we try to test the robustness of these results. I'm not going to get into exactly what they mean, but in research, oftentimes we want to throw a lot of different assumptions at it. And as long as the numbers come out consistently, it assures us that we're onto something. And that is the case here. One thing to note about schools and houses of worship down there on the right, so there's different sample sizes here. We have a lot more commercial and government buildings in our data, a lot fewer schools, and then far fewer houses of worship. So the commercial and government's like in the tens of thousands of systems. The schools, is, I think it's like 3,000, and houses of worship is less than 2,000. Sample size matters a lot. In general, we'd expect larger sample size to kind of support larger effects. In the paper, we talk about that. We look at some ways to kind of normalize the results across the different sample sizes. And we find some evidence that the effects across the different building types are more similar when you account for those differences. So here it kind of appears that maybe schools and houses of worship are not influential. I think a few minutes ago, I just suggested the opposite. We have this kind of ex ante hypothesis that maybe houses of worship are particularly influential because of previous research showing that houses of worship can influence the actions of their congregations. So we don't find good statistical evidence for that in the study, but there are caveats for that, and we explore that in the paper. One big difference with this and the first study, so the first study follows methods established in previous papers, and it essentially just looks at a one-off association on a single date, and it just thinks during the time that one system was installed, was there another adoption around that time? We had to take a different approach in this one, but what that allowed was it showed that maybe we could measure sustained influence over time. So if you think about the underlying theory, someone installs a system and then they talk to a neighbor, or the neighbor sees it, or whatever the mechanism is, there's no reason that that would diminish over time. That could sustain for years. It could be 2 years down the road. And as I said, someone comes along and realizes their neighbor or a local business had installed solar, and that could be the influencing event. So with that in mind, we looked at the effects of influence over time, and our models would suggest that influence is sustained. So it goes far beyond this kind of first installation. So the figure here in the middle, you can think about that as the moment that a non-residential system was installed in an area. In this study, we use zip codes, if I recall correctly. So the left of that is all the time before that non-residential system. And then the y-axis is this effect. Is there an observed increase in adoption? So before the non-residential system is installed, we see that effect just randomly vary around 0. which is what we'd expect. After the non-residential system is installed, we see kind of a lag. There's not really a clear effect for a few quarters, and then it picks up and is sustained over time. And this would suggest that two things. One, influence might be lagged, which would make sense if, say, a library installs solar. It might take a few months for people to realize that it's there. And then once they realize it's there, it's going to take a few months before they're talking to an installer, and then it's a few more months to get the permits. By the time that maybe that influencing event leads to an adoption, easily 6 months, a year could have passed. So that it makes sense. And then the second would be that this seems to be sustained over a long period of time, maybe flattening out around a few years. But it's kind of a new contribution of the work to say this influence effect is persistent. Another thing we explored in this study was comparing the non-residential effects to the residential effects. It was pretty difficult to do. We don't have a good apples to apples comparison. We didn't come up with a way to perfectly compare this. But in the study, we did our best, and we came up with this way of making maybe an apple to pear comparison. And based on that, our high level conclusion is that the magnitude of influence seems similar. So residential households seem to respond in similar ways to the influence of a system installed on a non-residential building as they would to another residential building. So I'll wrap up with some conclusions from both studies and maybe some open questions. So as maybe and to reiterate some of the key points, peer influence affects solar adoption decisions at all income levels. That much is clear. There's nothing unique about, even though solar has been concentrated among high income levels, influence is definitely important among low income household adoption decisions. We find that peer effects are weaker among low income levels, but reiterating that doesn't mean that influence in the abstract is less important. It just means that influence is less likely to lead to an installation, and that could be due to all the other barriers and challenges that low-income households face in adopting rooftop solar. We also find that peer influence is stronger within than across income groups. So again, a LMI household is more likely to adopt if they somehow interact with a previous LMI adopter. And then finally, social influence appears to work across customer types. We find pretty consistent evidence that non-residential installations on a variety of non-residential buildings affect residential adoption decisions, more specifically, increase the probability that households will adopt. And I'll close with some open questions, maybe suggested areas for further research. The first, and I've talked a lot about this throughout, are the mechanisms. So what are the mechanisms of influence in solar adoption? There's been some work on this, some research showing that visibility matters. There's been survey work which suggests that talking to neighbors matters, but there might also be other mechanisms that are a bit more subtle. So one could simply be that if one household adopts solar, they bring an installer into the neighborhood for the first time, someone sees the installation truck, writes down the number. There's all sorts of mechanisms through which influence can work and solar can become contagious. It'd be useful to do more research on that because if policy is designed around this idea of influence, ideally it'd be designed based on specific mechanisms. The second open question, could certain non-residential installations be more effective in influence? I suggested early on this hypothesis that certain types like houses of worship that have active relationships with their congregations, constituents, customers, whatever that group is, when those institutions adopt solar, they could potentially actively engage with those groups and increase the likelihood of adoption. And if so, maybe those non-residential institutions would be really good partners for policies like seeding. And the last open question is, how can all of this be used? it's really interesting to know that solar has this contagion effect and influencing adoption decisions across customers. But is there some practical way to use that? Do a policy that uses seeding or some other type of influence mechanism? These are 4 open questions for us. And then with that, I will turn to questions, kind of flash some acknowledgements in front of everyone, and then we'll turn to questions.
Great. Thanks so much, Eric. Really appreciate the presentation and the information. We've gotten a few questions so far, and I know this was just posted in the chat, but if anybody does have a question, please post it in the questions section in your panel. Let's see here. The first question is asking for more thoughts about how peer influence results might have different dynamics at different points in the typical adoption/diffusion curve mentioned.
Well, I guess my thought would be early on, it's likely going to be much more important. So what the question refers to is diffusion is often characterized by this curve, which takes on an S shape. So early on, it's kind of flat. People are hesitant. What is this new technology? You have some brave souls who are willing to test it and invest in it. And around that time, I'm sure that it takes a lot more. If you hear someone took the dive and, hey, it actually works and I'm saving money, that might get someone else to adopt themselves. The next step in the diffusion curve is it takes off. So you have a flat for a while and then it takes off steep. At that point, it's mass adoption. It's widely accepted. People are convinced to some extent that the technology works or is useful. So I would say it's around now. We're still in the early stages of solar diffusion. It's right around now where influence is presumably more important.
Yeah, I agree with all of that. I think, another way of thinking about it is when, say you see a neighbor install a PV system, in the early days of adoption, it's sort of like, oh, I could do that too. In the later days of adoption, when you see that, 80% of your neighbors have done something, it's like, oh, wow, I really should do that. So there's maybe a different psychological mechanism that sort of operates depending on where you're at within the sort of the overall adoption curve. And I can imagine that, in the measurement of peer effects, that, those differences might show up.
Great, thanks for that. Then we have a couple questions related to study 2. Does it try to distinguish over time the initial peer effects of a non-residential installation from the secondary residential to residential effects that might come from the residences that install affected directly by the non-residential installations?
Great question and very observant. So in the paper, we talk about that. We did a full webinar just to Study 2 a month or maybe a few weeks ago, and we talked about that. So yes, the question is kind of about this compounding effect. If you think that a non-residential system, say, influences a few households to adopt themselves, those households then go on to be a source of potential influence. So you have this buildup of influence upon influence upon influence. That we suspect is absolutely one of the reasons why you see that influence increase over time. The answer to the question is no. We did not try to distinguish that. The initial effect, we didn't try to tease it out from subsequent effects. We essentially took the approach that any influence that is indirectly down the line linked back to that first event. But precisely for that reason, we didn't look too far over time. At some point, 20 years after the initial installation, it's hard to draw the chain of causation back to the initial influencing event. But we definitely think that there's something like that going on.
Great. And then this next question kind of combines the 2 studies. You said impact on non-residential installation is similar to installation of residential, How does this apply to LMI versus non-LMI? Does non-residential influence non-LMI more to adopt? So are those correlations similar?
We don't know. We didn't. So in the second study, we didn't look at income levels. We began considering that. One of the motivations for the second study was around this notion of houses of worship specifically. And there is theory out there, there's literature out there that would suggest that certain non-resident institutions and community leaders are particularly influential in LMI communities. So there could be, there's hypotheses either way. Either you have certain non-resident institutions that are more likely to influence LMI and less likely to influence non-LMI, or vice versa. It's a good question, but no, we didn't look at that.
And then a question about the methodology related to proximity, like what is considered a peer. So I'm not sure if it was mentioned, this person asking the question, I wasn't sure if it was mentioned in the presentation, but yeah, what is the range of area for what's considered a peer and the impacts of proximity?
Great. In the first study, we used census tracts, which are a bit smaller than zip codes. In the second study, I think we used zip codes, if memory serves. And it's a good point because we use this term peers. A lot of people use neighbors, and to some extent, neighbors might be better. It's essentially saying peers are those who live near each other. And more specifically to this question of proximity, there's been other research showing that the peer effect diminishes over space. So clearly, if you look at maybe a block, the people living on that block are more likely to be influenced by a system than the people living in the next block, and less so in the next block, and so on. So there's obviously always some choice about where to draw the line. We use tracks as a convenient, practical way to do it in the study.
And is that's true for both of the studies?
Yeah, in the second one, it's, I think we use zip codes, and it's the same idea. So by definition, the second one's kind of less about peer effects, and the second one is useful. We explore some of the shortcomings of using that term peer effects for that reason. Is it really about peers, or just kind of this proximity? You know, if I decide to adopt because I see solar installed on a pizza shop, I'm not a peer to the pizza shop. So it's more about just broadening that concept of influence.
All right, next question is about seeding. How might, quote, seeding overcome the existing barriers, particularly for low-income residents?
Good question. So one thing I emphasize is that influence doesn't necessarily overcome some of the practical barriers. So the two key ones that I mentioned are, it's very difficult, and remains so, for renters and those living in multifamily buildings to adopt. Clearly, seeding is not going to overcome that. Other solutions are required. But I do think there is a lot to say for the amount of confidence that's required to adopt solar. For a low-income homeowner, it is a big risk. It can be a big investment depending on how you finance the system. And that in itself is a hurdle to think, can I do this? And if you begin learning, well, a lot of your friends, neighbors in similar shoes as yours are able to do it, it can increase that confidence. And that is a barrier that's harder to measure, that I think seeding could overcome.
All right, somewhat related. First, the person says, I love this research, exclamation mark. Was there any consideration of how the sales techniques, i.e. door knocking, has served or impeded adoption? I would assume no, but just wanted to make sure.
No. I mean, the quick comment on that is like I mentioned, that in peer influence, I think the installer is often ignored. So I think it matters. I think the way that solar is marketed does matter, but no, we didn't explore that here.
lot of good questions. And again, if anybody has a question, please post them in the panel. Let's see. Are there any recommendations for solar program administrators or developers on way to increase LMI solar adoption based on these studies? So are there any additional takeaways or best practices?
Yeah, so I mentioned one. I'll unpack here, that if you think about an incentive program, just for instance, but it could be anything, there's kind of two ways that you could design an LMI incentive program. You can either say any income qualifying household can come apply for this incentive, and if you earn less than 80% of area median income, you get the incentive. That's very common. A second way is to say, if you live in this area, you live in an underserved community, based on your zip code or whatever it is, you come to us and you're eligible, and we give you the incentive. So it's defining eligibility based on household or geography. Results like this would suggest that the geography can be more effective. And the reason being, if you imagine an income qualifying household that comes and maybe there's a few that get incentives, but they might live in a rural area or in a otherwise affluent area, it kind of mutes that influence effect. But certain programs, like some in California that do geographic eligibility, the results would suggest that that would put systems into low-income communities, which increases the probability that other low-income households are going to be influenced by the systems that were initially incentivized. So it's not cut and dry. I mean, I'm absolutely not saying it's a lot of different ways. We do lots of research on different LMI incentive programs, plenty of research showing that they're all effective, but it suggests that there may be some utility in looking at different approaches and defining eligibility.
Great, thank you. This is somewhat kind of tangential, but somebody interested in knowing if there is any similar research regarding energy efficiency improvements which are less visible but could be promoted with signage, etc. So I know this is focused on solar, but if you're aware of anything related to energy efficiency programs and peer influence. It's not as visible, so I guess it's maybe a little bit harder to identify.
Yeah, this is a question that's come up before, and no, I'm not aware of energy efficiency. The other example that's come up before is heat pumps. You don't see heat, well, at least heat pumps are not as visible. There's been a lot more influence work around rooftop solar and electric vehicles because they're just very visible and salient. So I don't know. I don't know if Galen, if you know any research on that.
No, I'm not aware of any.
Well, I think that covers all the questions we've gotten so far. Really want to thank Eric and Galen for their presentations today. Do either of you or both have any parting words or anything you want the folks in attendance to know? Well,
Thanks for joining. I'm really glad to hear that at least one of you out there loved the research enough to add exclamation points. It's always nice to get some feedback on that. If you are interested in the second study, I think one point is that there's the link that will be in this recording and the slides. There's another webinar, not that you want to hear most of it again, but in that one we had a guest from Revolve that talked a bit more about like the practical implications of the research. It's kind of in the second half of that webinar. It might be of interest.
Well, thanks again. This is really important research information for us to have. One comment that just came in, thank you. This is going to be so valuable with the implementation of Solar for All across the country and making sure that those programs are deployed in the most equitable and effective ways. So thanks everybody for joining the webinar today. Everybody who registered will receive an email with the recording and it will be posted on our website. So thanks again. Have a great day.
Thank you. Bye.